we want to show that the area under a curve is given by the integral of that function. So here is an arbitrary function, f of t. The x-axis here is given by the variable t. And what we're going to do is we're going to try to calculate the area under the curve over this region, so from t0 to tf. So let's go ahead and do that. The way we're going to do that is we're going to split all of this area into little tiny rectangles, right? So we're going to take a whole bunch of little tiny rectangles and add them all up together to get the area under the curve, right? So that's the basic idea. And so what we're going to do is we're going to take this region that goes from t0 to tf, and we're going to split it into these n rectangles. And so the edges here is going to be t1, t2, t3, t4, all the way through tn. So tn is going to be the final edge, and that's going to correspond to tf, right? And the width of each rectangle is going to be some tiny amount of time delta t. So this width over here is going to be delta t. So let's go ahead and compute the area under the curve. So we start with this rectangle right here, the very first rectangle. And so the base of the rectangle is delta t, and the height of the rectangle is given by the function f of t at this edge, f of t0. And so the area of this first rectangle is going to be f of t0 times delta t. Great, let's move on to the next rectangle. So here's the second rectangle, same thing as before. The base is delta t, and the height is f of t at the edge of that rectangle, which is going to be t1. So the second area is f of t1 times delta t. And we can keep going this way, right? So for the third rectangle, the base is delta t, the height is f of t2 times delta t. And we're going to keep going like this, and we're going to add all of these areas together. So the total area is going to look like the sum of f of t times delta t, where this thing is being evaluated at t0, t1, t2, t3, and so forth, right? And so this is going to look like this sum. But to really get the area, we need to take the limit in which delta t becomes narrower and narrower, right? So we're going to take the limit in which delta t goes to 0, and so that means that this sum is going to turn into an integral. So the bottom line is that the area under the curve, what you get when you add over all of the rectangles that have infinitesimally small widths, you're going to get the area under the curve. So the area under the curve is the integral of f from t0 to tf. And that's what we were looking for. In particular, this means that if we're interested in the displacement of a particle delta x, we know that the displacement of the particle is given by the integral of the velocity. Well, we know the integral gives us the area under the curve. So the displacement, delta x, is the area under the curve of a graph of v versus t.